Okay, kids, you're on hierarchy of quadrilaterals today, and I'm going to show you a little bit of a hint. Here, one of your questions may look like this. Follow along with me. By the way, you have a Venn diagram at the bottom, a little bit different than maybe you've seen sometimes. Maybe some of you have seen this. But the question is this: polygons are closed figures. We know that. Quadrilaterals have four sides. And parallelograms have opposite sides that are parallel. Okay, we know all that. We talked about that this morning. Parallelograms are a subcategory of quadrilaterals, and quadrilaterals are a subcategory of polygons. Now, look at our Venn diagram. Inside the big circle are polygons. Everything that's in the circle is a polygon. Now, ask yourself, is quadrilateral circle, is it inside the polygon circle? Yes, it is. So all quadrilaterals are polygons because they're in the polygon circle. They're a subcategory. You've heard of category. They're a subcategory, part of the category of polygons, under the category of polygons. Parallelograms, part Z down there, are they in the circle of polygons? Yeah, it's completely in the polygon circle. So all parallelograms are polygons. And if you look closely, all quadrilaterals are polygons. Remember, because all quadrilaterals, that circle on the inside, is also inside the circle for polygons. Now, are all quadrilaterals polygons? The question of that is no, because only a part of the quadrilateral circle is inside the parallelogram circle. Some are inside, quite a few are inside, and some are not. But all parallelograms are quadrilaterals because all the parallelogram part of the circle is inside the quadrilateral part of the circle. Okay? You just imagine it like this. So let's answer this question. Sophie draws a closed figure, that's a polygon, part of that has four sides, that's a quadrilateral, and opposite sides parallel. Which part of the Venn diagram does that belong? Well, if it's closed figure, all of these are closed figures, right? Because all of those are polygons. If it has four sides, it's a quadrilateral. So it's at least in the circle that's the Y circle. And since it has all sides, opposite sides parallel, that's a parallelogram. So that belongs in Z. Z would be the correct answer. Because if it's in Z, it's automatically also in Y and X, okay? Everything in Y and X is also in Z down here in this circle because this circle includes or fits into Y and X. All of Z is in Y and X. So everything that would be in Z fits in Y and X. That would be the answer. Okay, how about this question? A parallelogram is always an example of. Now think for a second, a parallelogram has to have opposite sides parallel. What does a rectangle have to have? Yeah, a parallelogram has to have opposite sides parallel. A rectangle is a parallelogram. A rhombus is a parallelogram. And a square is a parallelogram. But is a parallelogram always an example of a rectangle? Is every parallelogram always a rectangle? The answer is no. Is every parallelogram always a rhombus? The answer is no. And is every parallelogram always a square? The answer is no. No on all of those. Now, if you work backwards, a rectangle is always a parallelogram, a rhombus is always a parallelogram, and a square is always a parallelogram. But I can draw a parallelogram that's none of these. Example. And this is a really bad, terrible drawing. Let me fix that. real quick. It's my best shot at a parallelogram. Oh, this is terrible. I know you're laughing. It deserves it too. Okay. Now, is that a rectangle? No, because there are no right angles. Is that a rhombus? No, because there aren't equal sides. Is that a square? Certainly not. So that's a parallelogram that's none of those. So the correct answer for this question would be none of those. Okay, got that? So you have to read the question correctly and make sure you're going in the right direction using your chart. Okay, in the right direction. Which of the following is also classified as a rectangle? Rhombus, square. Which one is always a rectangle? Okay. All right. Good. Keep working on that, and I'm sure you'll do a good job. And remember, your all of these look similar. And remember this: everything that fits in the rectangle section of this Venn diagram is also completely in Y, the parallelogram, and all of Y is completely in polygons. But all of polygons is not inside rectangles. Do you see the difference? All the rectangle fits inside the polygon, but only part of the polygon fits in the rectangles. So you have to know it from both angles.